Okay, we're going to try an excellence level question with relative velocity. So this is definitely going to get more difficult. And it's easy to kind of recognize it. I'll show you the key word. It is must. It's one of these must questions. So this time, you have to travel in a particular direction. So here we have a boat, given it's 14 meters per second in still water, but it has to travel east across this river, and the current of the river is flowing south. So once again, like the previous question, we're going to draw two diagrams. If the current's going south, the banks are vertical. There's our velocity diagram. And then we're going to do the same thing for displacement. Banks are vertical. And the current is going towards the south. Good. Now, if you have to travel east, what I really recommend anytime you're doing a must question is I want you to put where you're starting. So we have to start kind of over here. That's the starting location. And I have to end up directly east from there. So this is where I must finish. So that's what I recommend you guys put first. I have to end up here. So here comes the question. Which direction would you aim your boat to make sure you end up at that location? Now the logic of this is that if you aim your boat directly to the east, can you see the current is going to push you south and you're going to end up going this way, which is not good. We're not allowed to do that. So that is not the way we want to aim. Instead, the logic is you're going to aim upstream. If you thought that, nicely done. And in fact, this is what we call the no current direction. In other words, if you aim your boat in this direction, and let's say the current stops for some miraculous reason, and there's no more current, well, that's exactly which way you're going to travel, diagonally, and you will travel at 14 meters per second if there's no current. But then we add the current to it. So to the tip, we now add the current that's going south, and that'll bring you back towards where you want to go, and that would be at 8 meters per second. That represents the current. So now we've added the current to it. And the resultant, the nice thing is, goes from start to finish. Like that. And there's your actual velocity with respect to the ground. And then we can put the angle you aimed in this triangle. There's your angle that you aimed the boat. So it's a harder diagram. Now I want to show you why this actually makes sense though. Can you guys see that 14 is the hypotenuse? That's the longest side, which means V has to be less than 14. It's going to cause your boat to slow down. That should make sense because you're aiming against the current. Remember, when you go against the current, you slow down. That makes sense. Now, what about the displacement diagram? How would that look? Well, remember, displacement goes in the exact same direction as the velocity. So if you must travel east, well, guess what? You travel east. That's the delta D. Your boat goes straight across the river directly east. And it turns out that goes from bank to bank. So that would be 120 meters. So that one doesn't even require a triangle. Don't draw a triangle for this one. It is simply just a straight line. Okay, now we finish up this question by doing, first we're going to find out the direction the boat aims. We've got to find theta. Now do you notice relative to theta, 8 is opposite and 14 is the hypotenuse. So that's going to be the sine of theta being opposite over hypotenuse. So we do the inverse sine. So if you take the inverse sine of both sides, you get about 34.85 degrees. And so that will round to 35 degrees, 2 sig digs. In this case, that would be north of east. Good. So now we know which angle we're going to be going at. Let me again just copy these two diagrams for the next part. So the next question, and our last question, is how much time would it take to get across this river? Well, can you see that if I'm going to use v is equal to d over t, I have no choice but to use the 120 meters for delta d, which means I have to use v. They have to be going in the same direction. So remember, I'll just make this clear. If I'm going to use this horizontal distance for d, I have to use the horizontal speed for v is d over t. So I've got to find v first. Let's do that then. So a little bit of Pythag, and notice that v is not the hypotenuse this time. So we have v squared equal, sorry, almost made my own mistake. V squared plus 8 squared is equal to 14 squared. So v becomes equal to the square root of 14 squared minus 8 squared. Square root that. It's about 11.489 meters per second. Notice that's slower than 14. It slowed down. Finally, v is equal to d over t. So t becomes equal to d over v. The distance is 120 divided by 11.489. And that's about 10 to 2 sig digs. Done. So just remember this, when you're doing a must question, when you're actually doing a question that involves must, draw the start finish first, and then you're on your way. Good luck. That's a synthesis, an excellence level question. It's a hard one. Good luck on the homework.